Good evening, everyone. And My name is Jikky Jayakumar. I'm PhD scholar from the Department of Food Process Engineering, TNAU. My work is extraction of natural pigment, bixin, using improved methods. And the bixin is the pigment that is obtained from the plant called anato, which is a tropical shrub or a tree that grows to the height of 8 to 10 meters. So the trees are mainly grown for its seeds. So the seeds which contain various pigments, the main pigment is called the bixin, which is a fat-soluble one, which accounts about 80 percentage. In case of the minor and the secondary pigment is the norbixin, which is a water-soluble. So in most of the countries like Peru, Kenya, and Brazil, they are growing for these seeds, and they usually immerse the seeds in the oil to prepare the for culinary purposes. Other than that, they'll export this seeds as such. In India, it is grown as an agroforestry plant and also as an ornamental plant. The plant, as well as the fruit and the extract, is commonly shares the name anato. So, in market, they name as anato extract, which contain numerous pigments, not only bixin, norbixin, some keratin, and it is found to be the one of the natural food colorant, and which ranks as the second in the world next to saffron. And from the pericarp of the seed, we can obtain the color ranges from yellow, red, oranges. So it had a wide scope in the industries like cosmetics, textile, and pharmaceuticals, and major in food industry. The main scope is in the dairy sector. According to the European Union, they consider this as one of the and they have designated as the code E160B. In India, the main production is in the central part of the India, like Madhya Pradesh, Orissa, and Maharashtra. And in southern part, it is mainly distributed in the areas of Tamil Nadu and Kerala. So the main objective of my study is to produce a natural colorant, since the consumers and even the producers, food producers, are very aware about their human health and the use of artificial colorant that which causes to chronic diseases. So the my objective is to extract the maximum bixin from the annatto seeds along with some antioxidants by optimizing the process conditions using the improved methods like microwave assisted and ultrasound extraction technique. So this is the general flow for the production of the bixin. So produce is obtained from the raw material fruit. So inside the fruit there will be numerous seeds. So the seed pericarp only contains the all compounds pigments, and these fruit have to be dried for 1 to 2 days or 1 week under sun drying. Then after that, it should be shelled and cleaned to get get the dried seeds. Then after that, further drying is needed to obtain a maximum moisture content of 8 to 10 percent. And after that, it is subjected to extractions of different methods like sock sled, conventional methods, and the improved methods are also be followed in research purposes. Then after that, we'll get the extract. So in my studies, I have used microwave assisted extraction for the bixin. So here I have changed the variables like power, time, and solvent and C to solvent ratio. And I have used the solvent ethanol and methanol, considering the reliability and the cost and dielectric constant of the material. Since I'm using the microwave assisted extraction, since the bixin is fat soluble, I have chosen this polar compound. And from the microwave assisted extraction, we can see that after extraction, there are some seeds without some red coloring. So that is obtained as an extract. From the graph of the bixin content and the phenol content, we can understand that the mild power range of 600 watts and increasing in time and a low C to solvent ratio has um, induces the material to diffuse into the solvent. So here I can see that using the dielectric constant of the solvent that I have used, there is only 1 to 3% of extraction of the bixin along with the phenol content. Then moving to the ultrasound assisted extraction of bixin, I have used the sonication bath with a 200-watt power and 40 kilohertz. In this, I have come to know that ethanol is the best solvent to extract the bixin along with the phenol content by increasing the C to solvent ratio and the time, which shows that the ethanol, which has the high boiling point, can withstand the ultrasound power to make the movement and cause the cavitations to extract almost all the bixin as well as the phenol content from the seeds. And moving to the SEM and the HPLC analysis, the first raw seeds, we can see that there are shiny parts covered all over the seeds. But in the case of microwave assisted extracted seeds, we can see some parts is only getting extracted. Where in the case of ultrasound, mostly 80% of the seeds are extracted by using the cavitational forces. From the HPLC graph, chromatogram, we can see that the ultrasound assisted extractor with the retention time of more than 28.5, when we compare to the standard Bixin of 28, the trans Bixin is obtained, which is a standard and it is a stable form of Bixin, so which can be utilized for all the purposes and without any microencapsulation or any other things. So the conclusion of my study is that adopting the microwave assisted extraction for Bixin, it is to better to use ultrasound assisted extraction method to extract the Bixin compound, with the ethanol being a reliable solvent that is obtained from the market. So I have yielded about 91.25% of Bixin, and the total antioxidant activity of 645.15 microgram per gram. And I also found that it contributes to the production of the transbixin, which is very useful for the dairy industry and the beverages industry and candy and savories. By adopting the ultrasound extraction method, it is very easy to extract the medium polar compound called bixin from the N2C. This is the finding of my research work, sir. Thank you.